Now that we've sort of set up the motivation behind ArrayLists and we've just introduced them, I want to now talk to you about some of the common operations that we can use when working with an array list. Because with an array, we can create something like this, and then we can change an element by doing this. We can use an element in some expression by something like this. But that's really it. We can't add anything dynamically. We can't remove anything dynamically. We can only set elements, and then that's pretty much it. Array lists are much more powerful. So how do we create an array list? Well, we saw before that we need to first use list, because that's just what I'm telling you to do. And we also have to put the type of data that's in the array list inside of these angle brackets. Okay? So remember that if we're using a primitive, we can't just do list of int, we have to use the wrapper class. Okay? So let's create an array list called L, and you'll notice that when I did that, we have to import some statements here. So we have to import some things here from Java. Okay? So by default, Java does not recognize these two classes, so it has to bring them in from this what's called java.util package. Okay, so you don't need to memorize these. You can always just, if you hover over this, you'll see import class, or you can press Alt-Enter on Windows, or Option-Enter on Option-Return on Mac. So yeah, now the thing is, what exactly is happening here when we create this array list? Well, we know that it's going to be empty, but it's more correct to say that the array list is going to have an initial capacity of sorts. We don't know what that initial capacity will be, but let's just say for now that it stores a bunch of, or that it can store up to 5 elements. Okay? So when we then add an element, we can do that by calling .add, then that means that the list will contain exactly one logical element. So this really brings up the difference between what a logical element is, or the logical element count, versus the capacity of the array list. The number of logical elements corresponds to how many actual values are in the array list. I think we would all agree that there is only one number in this list. It's 42. There is the potential to add more, and that goes into the capacity of the array list. But we don't need to know or care about the capacity, because that's getting into how the array list works, and for the time being, we don't care about what that is, or how that works. Okay? So, if we want to get the size of an array list, let's just print this out. We can do that by doing, you may think we can do something like L.length. Well, that's not going to work. And you may think, okay, maybe it works like strings and we can do .length as a method. And no, we can't do that either. With Java, you have to do .size. Okay? So what we can see here, if we print this out, is that there is one logical element in this list. So .size returns the number of logical elements in the array list. Okay? So now let's do something like L.add 1, let's add 6, let's add 24, let's add 120, and then let's print out the size again. Of course, we would expect this to be 5, because that makes sense. But now the array list is going to look something like this. So we can do 1, 6, 24, 120. But now, what happens if we try and do L.add, let's say 720? Well, if we print out the size here, it's going to work no problem. We're going to get 6. But the question is, how exactly did this happen? Well, under the hood, as we'll see in the next video, Java actually expanded this array list. Okay? So under the hood, it actually gave us more slots that we can put stuff in. And then it just put the 720 in that next slot. Okay? And also we can view this. We can see what the elements look like by just printing it out like this. We can also call what's called the toString method, and that will convert this array list into a stringified representation. So a stringified representation, as you'll see, looks like this. It's just the elements surrounded by brackets, and separated by commas and a space between elements. Okay? And notice that there's no mention of the actual, we don't care, again, we don't care about how many elements can be stored in this data structure, in this array list, because, why do we care? Well, we don't. We just care whether we can add elements and remove elements and insert elements and set elements and things like that. So let's do that. Let's see what that looks like. So let's do L dot, let's say we want to set an element. And setting an element is kind of what you would think it would be. What that means is that we're going to change what an element is at a given index. So let's say we want to change the 6 to be, let's say, 2000. So we're going to pass the index, and then we're going to pass the element that we want to pass, that we want it to be. So we're going to change this to 2000 just to give a representation. And now let's print out the value L. Okay? But you're going to notice my cats are going crazy right now. Sorry. You will notice that now the 6 is a 2000. Okay? Let's say we want to insert an element. So inserting an element at a given index is done by calling add with 2 values instead of 1. The first is always the index we want to insert it at. So let's say we want to insert something at index 4, which would be right here. Okay? So let's say we want to insert the value 1000. Well, what the ArrayList is going to do is it's going to shift everything over by 1. Okay? So we're going to input the 1000, and then everything to its right is going to shift by 1. And we'll see that if we print it out. And indeed, that did not work. That's because we didn't print anything out. I don't know what I thought was going to happen. There we go. Okay, so we get exactly what we think it would be, so we're good. Okay? Now let's say we want to remove something. If you want to remove something at a given index, then we can do so by just passing the index. Okay? So the thing is, let's remove the value. Let's remove the 2000 or let's remove the 24. It doesn't really matter. So what do you think is going to happen? Well, if we insert something, things shift to the right, but if we remove something, things shift to the left. So if we remove the 24, everything just shifts down by 1. Okay? And again, I don't know what I thought would happen because it didn't print anything out. But now as you can see, we get 42, 1, 2000, 1000, 120, 720. Okay? Now we can do anything with ArrayLists, okay? These are very powerful data structures. So for example, if we want to, let's say, take the sum of all of the elements of the list, then let's first create a variable for the sum, okay? And then we're going to go from I equals 0, index 0, up to the size of the list. Because ArrayLists, like arrays, are indexed from 1. They're indexed from 0. I don't know why I said that. They're indexed from 0. So we're going to say L.size, and then we're going to do I++. Now we're going to say sum plus equals sum plus L.get I. So to get the ith element of a list, you do L.get I, which is basically like saying L at I. Okay? So the sum of this should be, I don't know what the sum of these values are, but we can trust that it will be correct. And 3,883 seems correct, because 42 plus 1 is 43, and there's no other value in the ones place, so we can take this for what it's worth and say it's correct. Okay? Good.